Greetings, transition math students. We're going to take a look at section 2.3, which is another look at rational equations. So those dreaded fractions and how we can solve equations that have the fractions in. And in fact, we're going to talk about a slightly different method called the LCD, or least common denominator method, to clear fractions. So let's get right into it. We're just going to look at about 3 examples today is all. Then you should be good to go on that Google form. So here we have an equation. It's got 3 parts. And do you notice that the denominators are not the same here? We have 3, 4, and 12. So here's what we're going to do. You ready? We're going to upgrade all the fractions to have the same denominator. And then we'll talk about the next step. So let me ask you this. What would the common denominator be between 3, 4, and 12? What is the first thing that they all go into, that they all divide into, the first multiple? What? Yes, 12, 12. So we're going to upgrade them all to be something over 12. In fact, the right side is already over 12. How cool is that? So we got that part right at least, right? Now let's take a look at the first fraction. We have something over 3, but we're going to turn that something into something else because we're going to turn the 3 into a 12. So what's it take to turn a 3 into a 12? It would be multiply by 4, right? Well, when you're dealing with fractions, if you don't want to change the fraction, you have to multiply by the number 1. That doesn't change the fraction, but yet we're not going to multiply by the number 1. We're going to multiply by something over itself because that's the same thing as 1. So we are allowed to focus entirely on one part of the equation and just multiply it and it alone by the number 1, in this case 4 over 4. So 4 times 3 is 12 on the bottom, and on the top I now have 4 times the quantity, x plus 1. Perfectly legal move is to just multiply that one term by the number 1. Now we're going to go to the second term here. I'm trying to change my color and my pencil has turned off. There we go. Fancy Apple Pencil. All right, so now we're going to try to turn a 4 into a 12, which we know we can do. What's it take? It would take a multiplication by 3. But we can't multiply by 1 over 3 because that would literally change the fraction. We have to multiply by the number 1. So we're going to multiply by something over itself. In this case, not 4 over 4. Hopefully you didn't write that in pen. 3 over 3. See, that way 4 times 3 gives us our 12 that we want. So what do we have on the top? 5 times 3 is 15. 15. Now, some of you are thinking, oh my Lord, this doesn't look like we've made progress here. This looks actually worse than the original problem. But here's the cool part. You ready? We can now multiply. Listen. We can now multiply both sides by 12. In fact, we can just nuke all the fractions. If we multiply, we don't have to show this work, by the way. We don't even have to show this work. We could multiply everything by 12, and what's going to happen is all the denominators will cancel because they're all the same. Get it? So now the next step is 4 parentheses x plus 1 plus 15 equals 7. You see, we're home free now. Then you just solve the equation just like normal. And I'm kind of running out of room here, so I'm going to, I could zoom in and write smaller, I guess. So this would be 4x plus 4 plus 15 equals 7. 4x plus 19 equals 7. I now minus 19 on both sides. I'm going to come over here. 4x equals negative 12. X equals negative 3. We just solved a rather scary looking equation. I'm going to go ahead and delete some of my work there just so you can see what the original problem was. That was pretty epically scary, wasn't it? We're near Halloween time, so that makes sense that I would give that to you. A frightening problem like that. All right, you got it? Okay, great. Let's move on to another one. We're going to do this. This one's very similar, and we did one in class like this actually, and I did it a slightly different way. This time, instead, we are going to upgrade them all to be a common denominator. And then we'll just throw the denominator away. So what is the first number that 6 and 2 has in common? Oh, not 12. Some of you said 12. I heard it. It's actually 6. We could change them all to be 6. So this one doesn't change. This one I have to multiply by 3 over 3 to get there. So I got 3x on the top there. And then this one used to be 3 over 1, but now it's something over 6. So we have to multiply by 6 over 6, which is 18. All right, so if that did not make sense, go back, flip back about 2 minutes and watch that again. Now that all the denominators are the same, they don't matter anymore. I can literally just erase them because they're all the same. They're all the same. And now I can just finish the problem very quickly. 18 equals 2x, x equals 9. Put a box around it, put a bow on it. It's done. I guess I should say stick a fork in it. It's done. Okay, let's go to one more type of problem. As I was looking at your Google form assignment, there are a couple like this. Now, we could stay in decimal land, but let me show you a nifty way to do this. We can get rid of the decimals by taking a look and seeing how many digits after the decimal point do we have. Well, we have 2 digits after that, right? That's the 100th position. So what I'm literally going to do is multiply everything by 100. So I'm going to move all the decimal points over twice. I'm multiplying everything by 100. So I get 101x plus, I got to move this over twice, so I get 210 equals, got to move it over twice, 300. All right, so I moved the decimal point over twice. So there was a 0 there, 1, 2 there, and then there was a .00 here, and when I moved it over twice, I got 300. You see that? Now the decimals are gone, and we're in a happy place here. As always, whenever we're in math class, we're in a happy place. Isn't that true? Yes, it is. Divide by a hundo, actually hundo 1, we get x equals 90 divided by 101. Now, that's a decimal, and I'm not rounding at all. I've got the exact answer there on my paper, and I didn't need to go to a calculator. Okay, so we've learned a couple creative ways to solve equations. One is to get all the denominators the same and then just erase the denominator and make your life a lot easier. And then I also showed you decimal equations and how you can get rid of the decimals by multiplying everything by maybe 10 or 100 or 1,000. Okay, some factor of 10. All right, good luck on the assignment. Let me know if you have any questions. Take care, guys.